This is lesson 1.5, exponential notation. A lot of these concepts you would have talked about last year in Math 9, but we'll do a recap to make sure you remember. A power is a number raised to another number. So 5 to the power of 2, or 5 squared, is just 5 times 5, which gives us 25. There's two parts to a power, the base and the exponent. The base is the big number, or the number that's being repeated over and over. So like in that example, 5. And the exponent is the little number that's raised up above, and that represents how many times the base is being repeated. Another example here, 2 to the power of 5 is 2 times 2 times 2 times 2 times 2. And 2 is the base, and 5 is the exponent. You have to be careful when there are brackets, because if you have a big term in brackets, and that's to an exponent, then the entire thing in the brackets is the base. So in this example right here, in brackets, you have negative 5x, and that whole thing is raised to the power of 3. So the base is negative 5x. That gets repeated over and over to give you negative 125x cubed. But if we had the exact same question without the brackets, we have a very different answer. Because in this case, the negative 5 is just the coefficient out front. It has nothing to do with the exponent. The only thing raised to the power of 3 is the x, so that's the only thing being repeated over here. So just be careful when you're working with brackets and negatives. In Math 9, you would have learned a bunch of different exponent laws about how to simplify powers, and we're going to review those, and then we'll have one new exponent law. Anything to the power of 0 is just 1. So that's a simple one to remember. It doesn't matter what the base is. If it's to the power of 0, it just gives you 1. Anything to the power of 1 is just itself. It doesn't change. So 5 to the power of 1 is just 5 repeated one time. So it's just there once. It's just itself. So don't get these mixed up. And a common mistake is that people think anything to the power of 0 is 0. It is not. It's 1. The product rule is when we're multiplying powers. If you're multiplying powers with the same base, just keep one of the bases and add the exponents together. Again, common mistake is that when you're multiplying the powers, you think you also multiply the exponents. You have to add them. So in these two examples, we've got 6 cubed times 6 to the 5. That's going to give us 6 to the 8. We keep the base the same because these are the same bases, and add the exponents. Same is true if we have a variable base, just add the exponents if they have the same base. The quotient rule or the division rule is very similar. If you have the same base and you're dividing these powers, then just subtract the exponents. So 5 to the 10 divided by 5 to the 4 becomes 5 to the 6. Again, make sure you're subtracting the exponents, not dividing the exponents. The last one from Math 9 you would have learned is the power rule. So if you have a power raised to a power, then you're going to multiply the exponents together. So in this example here, we've got 4 to the 5. That whole thing is in brackets, so that whole thing is the base. And then that's the power of 3. So you're going to multiply the exponents together to give you 4 to the 15. Same situation in this example. We've got negative x to the power of 4, and then that whole thing is to the power of 10. So it's going to become negative x to the power of 40 when you multiply those exponents together. A helpful tip here, if you have a base with a fraction, like this example, an easy way to simplify it is if the base here is 2 over 5, and that whole thing is the power of 4, instead of writing it out as repeated multiplication, this is the same as 2 to the 4 over 5 to the 4. So you can kind of bring that exponent into the fraction, and the numerator and denominator will be raised to that exponent. A new exponent law in Math 10 will be negative exponents. So this is, hopefully everything so far has been reviewed, and this will be new. A power with a negative exponent can be rewritten as 1 divided by that power with now a positive exponent. So for example, 4 to the negative 3 is the same as 1 over 4 to the 3. You essentially just bring it to the bottom of a fraction, and now it's no longer a negative exponent. This is the most simplified form, so please write your final answers with positive exponents. So if you get a final answer of this, let's say, to the power of negative 5, that has to be written as 1 over 2 to the 5. You don't want negative exponents in your final answer. And this also works the other way. So if you had 1 over and then something with a negative exponent, that can just be flipped now to the front of the fraction, or to the top of the fraction. That just becomes 3 squared. So whenever you have a negative exponent, if you want to get rid of it, just bring it to the numerator if it's in the denominator, or bring it to the denominator if it's in the numerator. Essentially, just switch the position and the exponent will now become positive. Something to note is that we are not covering rational exponents, which is in the Michelson 10 book, so please ignore that. That is not in the Math 10 curriculum. Let's do some examples. There's a lot of examples here, so I'll go through some of them quickly, but you can review them in more detail on your own. We want to simplify these using exponent laws. The first one, they all have the same base of 5, so we just add the exponents together. To simplify it, we get 5 to the power of 6. Reminder that 5 to the power of 0 is just going to give you 1. Same thing here, we've got the same base of 3 over 4, so we're going to add the exponents together. And I just put a little reminder that this is simplified enough for our question, but if you wanted to calculate this, it can be written as 3 to the 5 over 4 to the 5. You can just bring that exponent into the fraction. This example here, a reminder that the entire base is negative 4x. That is getting repeated every time because it's in brackets. So we can write that out as repeated multiplication, or we can use what we just talked about. And this exponent basically applies into the bracket, to everything in the bracket. So it can be written as negative 4 cubed times x cubed, which we can then simplify. Our division rule next, these have the same base, so we subtract the exponents. 10 minus 5 gives us 5. Same thing when we have a variable exponent, or sorry, variable base, we're going to subtract the exponents. But in this case, our answer would be x to the negative 3. So reminder, you always have to write your final answer with positive exponents. You'll write it as 1 over x cubed. In this example, the base is a bit more complicated, but it's the exact same idea. You'll just subtract the exponents. We've got negative 3xy, and that whole thing is to the power of 4. And I put another reminder note that if you wanted to simplify in a different way, you can just bring that exponent in to everything in the brackets. So each thing in the bracket is to the power of 4. In this example 7 here, we've got our power to a power rule. So whatever's on the outside is being applied to every single thing in the brackets. So it's 3 to the power of 4, and we've got x to the 4, which is also to the power of 4, and same thing with our last term here. From here, we can simplify by just calculating what's 3 to the power of 4. You can either write it out, or you can just use your calculator to get the answer there of 81. And then we use our double power rule. So we would multiply these exponents together, give us 16, multiply these together to give us minus 8. And then for our final answer, just put the y to the 8 on the bottom of the fraction to only have positive exponents in your final answer. For this one, the first thing we have to do is get rid of our brackets because this 3x squared is locked in to those brackets, and we can't simplify with the denominator until we remove those brackets. So we'll kind of bring our exponent into the brackets here. So everything is to the power of negative 3. So once we have 3 to the negative 3, we can just bring that right to the bottom here. Because again, we only want positive exponents. If it's negative, bring it to the bottom. It'll now become positive. And for the x, we've got x squared times, or to the power of negative 3, which would become x to the negative 6. So I also just brought that right to the bottom instead of writing it on the top because we need positive exponents. So we're only left with a 1 on the top of this fraction. And then this x cubed stays as it is. But for our very last step, we can simplify 3 to the 3 is 27. And then we use our multiplication rule here to add our exponents to get us x to the 9. Last two examples, these are complicated ones. These are more the applying and extending level, but it's the same idea. We're using all our exponent laws to simplify. So in this first example, I brought the negative 2 into the brackets first. So 5 times negative 2 gives me negative 10. 2 times negative 2 gives me negative 4. Did the same thing with the second set here. Bottom stayed the same. The next step is I simplified the numerator first. I didn't even look at the denominator yet. So this x and this x can be combined by adding the exponents to get negative 4. And then I did the same thing with the y's. Negative 4 plus negative 6 is negative 10. Then I use my division rule. So I've got my x's here, negative 4 minus minus 1, and then negative 10 minus minus 2. That gives me this here when I subtract them. Don't forget that double negative. Then my very last step, because these are negative exponents, I write them on the bottom of the fraction. This one is a doozy. Again, this is like the higher level of applying or the extending level. So if this is really overwhelming to you, don't worry about it too much. Focus on the earlier examples. So the steps I did here is I kind of dealt with the left side and then the right side separately. Didn't deal with them together until the very end once I had simplified more. So the first thing is I brought these exponents into the brackets by multiplying, like everything is now to the power of -2. So like b to the -1 became b to the 2 because I've multiplied -1 and -2 together. So that was my first step here. What I did with my constants, I had 9 to the -2 and 8 to the -2. And remember, I don't want negative exponents, so all I did is flip their position. I brought the 8 up, brought the 9 down, now they have positive exponents. For my variables, I just use my division rule, so -2, -4, and then 2 minus -4. Same thing over here, but I didn't have to move the 3 and the 2 because they were already positive, so I just calculated what those values gave me. Next, yeah, I simplified the variables. I simplified the numbers here, which I did there. And then I brought the a to the -6 down to the bottom so that we have positive exponents. Same thing with the a to the -12. I brought to the bottom so it's positive. Then I finally dealt with these two sets of brackets together. So all the constants are getting multiplied. And then I combined the b's and I combined the a's. So instead of having a big mess on my calculator or on paper, I simplified right away because 64 divided by 8 just gives me 8. And then 81 divided by 27 gives me 3. So that was actually easier calculation than it might look like originally. And then this is fully simplified because the fraction is fully simplified and these do not have the same roots. So that is our review of exponent notation and exponent laws.